think we should get rocking, Scott?
Yeah, let's do it.
Okay, great. Well, thank you everybody that has joined us this morning. My name is Rebecca Warren. I lead product marketing at Stackhawk. And with me today is our Chief Security Officer and co-founder, Scott Gerlach. He's going to be walking us through how we can add application security testing to a GitLab pipeline. I'll be available in the chat throughout the session. So if you have any questions, feel free to drop them in there. And we try to do as interactive of webinars as possible and answer questions as we go. So no need to hold on to those till the end. So with that, I'll pass it over to you, Scott, to get going.
Awesome. Thank you, Rebecca. Yeah, we do have, there's not a whole ton of attendees today. It looks like there's 11. So if anyone has any questions or wants to call me out on some BS that they see in the slides or not, whatever, please let us know and I'll try to answer them real time and we'll have a really cool interactive session here. Excuse me, real quick. So I'm Scott Gerlach, as Rebecca mentioned, the CSO and co-founder of Stackhawk. Before that, I was the CISO at SendGrid for about 3 years, a senior security architect at GoDaddy for 9 years. I also am, more importantly, a husband and a dad, and I brew beer and I play golf and I take toasters apart at the house and then we don't have toast for a while until I order a new toaster, that kind of stuff. If you want to get a hold of me after this or any other time, there's my Twitter handle and also my LinkedIn URL. So today we're going to talk about why we want to automate application security testing, the shift to developer-centric security, types of application security testing. We'll talk about Stackhawk a little bit, and then we will tempt the demo gods and see if we can get through an example application that has an issue in it, fix it, and make it all work in a GitLab pipeline. This example is available. I forgot to put the URL to the example app in our slides here, Rebecca, but it's on the Kaka organization.
Perfect. I will get that
up. So we want to first talk about the cost of fixing security bugs. And so this is just the relative cost to fix security bugs as you move to different stages of the application production pipeline. So obviously, if you can catch them at requirements and architecture phase, they're ridiculously cheap. If you catch them at the production and post-release phase, they're insanely expensive. So the goal of kind of this developer-centric application security is to shift left, but move that testing and that information back towards the people that are writing code. So the engineers, the developers that are actually writing that code while they're doing that second phase here, and that's that coding phase. And then hopefully the tools are good enough to back you up in CI integration component testing so that your systems, your automated systems are making sure that you're not making mistakes. And you're saying, maybe you're saying to yourself, isn't that what testing is for? And yes, that is exactly why you write functional tests and unit tests and integration tests. And those failing tests check your software as you're writing it and in CI/CD before you commit code, and then also in CI/CD to make sure that they're backing you up, right? Telling you about defects before you get to production. But the problem is, how can you reliably find security issues without writing exhaustive tests for applications? So usually when we write unit tests and functional tests and integration tests, those are kind of positive test cases. It should do this, it should interact this way, it should do this on a web page. Writing security tests is like the opposite of that. It should not do this, it should not do that. And thinking about all of the different iterations of it should not is really, really hard. And that is why security tools built for developers makes this more better for everyone. So security testing isn't new. Developer-friendly security tools are, and you can see that in kind of how a lot of those tools are presented to end users, whether or not you can try them before you have to buy them or talk to a salesperson in a kind of freemium or a trial kind of mode. Being able to run that on your desktop or on your laptop and get the same results as you would anywhere else is also super important. But most importantly, tools that work in the flow of development result in less back and forth via tickets. And what happens here is the old way of doing this is a security team is running all of these tests once you put something into production, and they make a bunch of tickets, and then they heave those tickets over the wall back to development teams and go, here, you guys got to fix all this stuff. And which is super inefficient for 100 different reasons, but mostly because you've probably moved on to something else. So a lot of these issues can be easily resolved with an easy fix and recommit if you can know about it while you're writing the code that maybe has introduced the problem or it was a latent problem. Being able to fix it while you're in that context of that code is really important. And then this scales efficiently because we're putting those tests and results directly into the hands of the people that can fix the issue. The other problem with security team going, here's the mountain of tickets, is they can't fix the issues. So now the development team has to get back into the context and figure out how this test worked and why it failed and all these good things to be able to fix the code. Where why don't we just give the information to the people that can fix the code in the first place is super important. So that's where you see the difference between some of those security tools. Talk about some application security testing methods. And that is static testing techniques. So those things focus on examining source code and or dependency libraries. So static testing is looking at source code itself and looking at packages that you're using to build applications. So your open source libraries that you've pulled in, most commonly referred to as software composition analysis. And those things do not interact directly with the executed code. So they're looking at just the words that get written that turn into code, excuse me, that make the application. So they're trying to find issues there. And sometimes they lack context of, am I actually using this function in a public way? Am I using a library in a way that gets exposed to end users, etc. And then dynamic security testing is conducted by testing and interacting with the running application. So spinning up the application and testing it from the outside in as an attacker would. And then observing the behavior of the application. Does it handle that user input correctly? Does it sanitize it right? Or am I sending the right security headers? Am I handling cookies the right way? All that good stuff. Both of these are rooted in finding defects. So they're all really good and supplementary with their own strengths and shortcomings. Like I mentioned, some of the static ones, some of the shortcomings of dynamic testing are they can't go, it's this line of code right here. It's this one. This is the thing you need to fix. It's a little bit more interactive in how you debug that. We had a question in here. We can definitely integrate scanners to the pipeline, but can we expect developers to have security expertise to do false positive analysis and prioritize security vulnerabilities? I think so. And here's why I think so. Developers are really smart people. They're the ones that are actually creating all these applications in the first place. They're taking risks based on the code that they're writing. And maybe that's not the right risk, but they're documenting that in code. So if we give development teams the tools to be able to go, here's the risks that are popping up in your application, and you can document why you think it's a false positive, why you think we should risk accept it. Most oftentimes when I give developers this kind of information and say, what's your next step? They go, I'm going to go fix these things, which is crazy different than what usually happens in application security land, where we pass them a bunch of tickets and they're like, I'm not doing this. So empowering development teams to kind of control their own destiny is super important with all of these tools here. And then the security teams turn into, in my opinion, consultants to help people fix and prioritize what's going on with their application, because now they know about all the risks that exist in an application. And the value of a security tool is not finding all the problems, it's helping prioritize and fix those problems. So if you can deliver that to the people that can fix them quickly, great. If they miscategorize something as a false positive or as risk accepted and document that, that's awesome as well, because now we can go back and have a conversation about why it might get some more priority, or why it should, why it's not actually a false positive, those kinds of things. Hopefully that answers your question. let's talk a little bit about dynamic application security testing, which is what Stackhawk does. So you may be saying to yourself, why DAST? I've heard DAST is meh. DAST is not meh. DAST is awesome. We love DAST. First of all, there's no language dependency with DAST. So you can build applications in any language, specifically ours. If it exposes itself on an HTTP endpoint, we can test it. So you can be writing stuff in Rust, which doesn't have great support for static analysis or any other language, Go, that kind of stuff. Again, once it exposes its application on an HTTP port, we can test it. It also understands better how the context of that application works. So it's testing that running application like an attacker would to look for mishandled inputs and outputs, see how that application behaves. And then I think DAST actually has lower false positive rates. So this is one of the big knocks on DAST out there is it has a ton of false positives. We've done a ton of work to make sure that it's actually reporting the right kinds of things, scanning for technologies that you use in your app, all of these good things. And usually, if DAST finds a security bug in the application, it almost certainly exists. Whether or not you want to fix it is a different thing. There are cases of false positives for timing-based SQL injection, for instance, just trying to make the database server on the backside wait. And if your application is naturally slow, the DAST might think, and that might have worked. So you might want to dig into that. But I always think it has a lower false positive rate. And what I think of it is a higher actionability rate. So static code analysis, I think is very, very noisy, and it's really hard to figure out what you should action. Whereas I think DAST does a better job here. So Stackhawk allows you to find these security bugs in your application, quickly triage and be able to reproduce those alerts, manage those findings, and have the scanner remember. So this is another DAST hit, is like, it just keeps telling me about this stuff and I don't care about it. We've built it so that it remembers what is going on there. So you're starting to bring your attention to the things that are new that have not been handled. And over on the right-hand screen here, we've got a screenshot. So when we publish the deck later, you can kind of flip through the deck, but we're actually going to look at some of this in the terminal. Again, here's how DAST works. That DAST is making HTTP requests with malicious payloads and looking for the response with evidence of that payload being effective. So the things that it finds, you can think of this as OWASP top 10, but kind of OWASP top all, not prioritized in order. SQL injection and OS injection, operating system command injection, cross-site scripting problems. Again, I said cookie safety, content security problems, and a myriad other web application security issues that you would want to know about as you're publishing your app. And the other interesting thing about DAST, I think, is static code analysis and software composition analysis won't tell you about cookie safety or security header safety. So DAST is a really good augment to those programs as well because of those kinds of things. But it's also a great place to start. So here's our example GitLab pipeline. We are talking about running this, running Stackhawk in GitLab today. GitLab has its own DAST scanner. Hint, both of our technologies are based on the same underlying thing, and that is the Z attack proxy, which is an open source DAST scanner. We've done a ton of work to make our the HawkScan, the Stackhawk version of ZAP, much easier to use, much easier to consume the output and be able to run anywhere. So you can, again, run this on your desktop if you want, as opposed to just needing to send it into pipeline. So anything we can do in our pipeline, we can do on our desktop as well. And I will show you that also. Once again, the scan results here, you can see that we've got in this screenshot some triaged and new items in here. So I've triaged some of these anti-CSRF tokens as risk accepted. That SQL injection is a new, so that's one of those things that should be bringing attention to development teams as, hey, this is an issue. And the cool thing is you can actually break builds based on that. And we're going to look at that as well.
Scott, we got a question in the chat, which is, what are the security rules that have been defined in Stackhawk? Is it possible to modify these security rules?
Yeah, sure. So the rules that we use at Stackhawk are actually the Z attack proxy release and beta release rules. And then we do a little bit of tuning based on what you're actually scanning. So if you're scanning a REST API, we turn off a bunch of those HTTP looking rules that are just looking for HTTP code or responses in HTTP. Same thing with GraphQL. So we've done a bunch of tuning to make those rules make more sense. And I can show you some of that stuff as well, because it's actually turned on and turned off some of the rules in my Vulnerability Django setup here. Good question. What we have here is actually a screenshot of the Stackhawk platform. And as you can see, this is us triaging a cross-site scripting reflected issue. So, we're looking at the evidence here on the right side panel in where what the evidence is, where it's highlighted as where it went into the request or into the application. And then if we look at the response tab, which we will, it will show you where it came back out in the application. And it's assigned to that polls search path, or that's where the affected problem is. We're actually going to go through and try to fix our application today. This is the code that we're going to be dealing with on this cross-site scripting issue. And it's in here somewhere. We'll figure that out in a second. And then once we have it all fixed, you can see that these things have been either triaged or fixed. And now I don't have any outstanding highs, right? I still have these outstanding mediums and lows. And once again, we can break build there. And so a quick recap on Stackhawk. It's easy to get started. We actually configure the scanner. We're going to look at this too in YAML. And that YAML file rides along with the application you're testing. So everyone that pulls the repository can run the same tests as well as CI/CD. Works in almost every CI system. We're talking about GitLab today. You can check on every, look what I did here. You can check on every merge request. And then into the intuitive triage screens, there's multiple ways to address an issue, and there are lots of different settings there. Again, the scanner remembers what you've done with those that triage setting, so you don't have to readdress findings every time. And importantly, it gets out of the way. If there's no new issues, everything proceeds as normal. Get on with the business of developing features and fixing bugs and generating revenue for the company. And then lastly, this delivers confidence that you're not making security mistakes in the code that you write. So again, most of the issues that get found here are code that you have written, not in open source libraries, although it can potentially find those problems as well. So we're about to jump into the demo. Any questions here? Any questions in the chat? I don't see any new ones.
Nope, I don't see any either, but if people have those, feel free to drop them in. And I did just post a link if you would like to follow along with Scott as he goes through this demo. You can get a free Stackhawk account.
Yep, cool. Okay, so over here we're gonna pull up this thing, go to our Cacao repository, because I forgot to do this. Vulnerability Django play. So if you're following along out in the Stackhawk Cacao repository, we're actually working on the GitLab pipeline branch. That's the one that has all the GitLab stuff in it. There's other examples in this repository. This is the one we're using. You can follow along as well. However, here's what we're looking at. This is the code for our Vulnerability Django project. You can see it's the Django polls app. It's kind of the demo example app that if you walk through trying to learn Django, this is exactly what it is. It has some problems in it. And what we've got here is our simple Stackhawk YAML. So this is how we configure Stackhawk. Let's see. Better?
Read my mind, Scott.
Yep. Sure. I've done this once or twice. I can tell when Rebecca's like, that's too small. So importantly, these are the fields that are required to run a Stackhawk scan. So application ID, what environment are you in? And then where can I find the running application? Most of this comes out of the platform when you go through the create an application wizard. But the most important thing here is, where do I find the running app? The rest of this information in this file is how to make the scanner work better for your application. So you can see I can exclude things. I can set up authentication We haven't done that in this particular example, although it is set up to be able to do it. But we're going to run kind of a simple scan against the user interface, not the admin interface of this particular app. This is actually running in a Docker Compose file. So if you pull this repo down, you can do a Docker Compose up. All the services should come up. You should have a polls app running on your local host that looks like that. This is the Django, the polls application. You can see we've got some polls and some answers. This is all bootstrapped information. There's lots of good things in here, but that's what it looks like. And lastly, let's take a look at our GitLab CI. So you can see in our GitLab CI configuration file here, we've got a couple different stages that we've set up, test, build, and hawkscan. I disabled the test because it doesn't work quite right yet in Docker Compose land, but I'll get that fixed as soon as I can. You can also see that we're building our Docker app for our Django application. So if that build is correct, then we move on to the next stage, and the next stage is the hawkscan stage. So there's a bunch of information in here. What we're doing is setting up the Docker Compose images for the database and the Django application itself, firing that up in that pipeline. And then the last part there is running the Stackhawk scanner against it. And you can see there are a couple of things that happen here. And one of them is what configuration files get pulled in. So there are two configuration files that get pulled in here. And there's a good reason for that. And I will tell you what they are right now. So the regular Stackhawk YAML, I made Rebecca laugh. That's funny. The regular YAML has this environment set up as development, and it says the running application lives on localhost. That's for when I'm running on my my laptop here. When I put this into GitLab, I need to change some of these environment variables. Stackhawk supports overlay configuration. So by stacking another configuration file on here, we're changing the environment name to GitLab CI, and we're changing where that running host can be found. So in GitLab, while we're running our pipeline, that Django host will expose itself as vuln-django on port 8020. So now I've overridden some of those environment variables, which is why we have them stacked up like this. Any questions about that stuff before we kind of move on? Want to make sure everyone's kind of following along and it's not like, what? All right. So let's look at the pipeline. This is all set up. I ran the scan earlier today. Oh, there is one more thing I wanted to show you. This setting down here, failure threshold, tells hawkscan to exit non-zero if it finds a untriaged high issue. So you can set that to medium, and then it will break on medium and high, or low, medium, and high. I like high only. We'll look at what this looks like. How do you get the host name used in GitLab Stackhawk overlay? I set it myself. So in this Docker Compose thing.
For those of you that didn't catch that, we just got a question, which was how do you get the host name used in GitLab Stackhawk overlay?
Yes, so I set it myself. In this Docker Compose file, you've got a place where you can call all these services. This particular one is named right here. This is where you set that up so that other containers can find it. Make sense? Cool. Okay, so you can see the last build that we fired off here actually, break build question mark, actually failed this build, and we'll see why in a second. We actually, before I allowed this job to fail, sorry, too many clicks. Before we allowed this job to fail, you can see it was passing, but the Stackhawk version of the jobs running in here actually failed. So this failed, but I had it set up to allow this to fail and still pass the build. That might be a good way to configure your pipeline if you want to allow things to continue to go. Or if you want to be a little more strict about how that pipeline works and get people to actually triage stuff before you do that, you can set it to not allow to fail, which is this setting right here. allow failure false or true. So I changed this setting, which actually failed my pipeline build. So the same scan ran, I changed that one setting, and now I've got a failure here. So the failure is, if I click into that, you can see all the stuff that ran with Stackhawk and how it did what it was going to do. So it did a Docker run, Stackhawk. What that did was spin up and test those Docker Compose running services. The very first thing it did was crawl the web page to find all the interesting things to go test. Then it started testing them. You can see we found a couple of different issues. We're going to focus on this cross-site scripting guy. So we can see that it's got a polls search problem. I've already marked this as risk accepted before. We're going to undo that because we don't want it to be risk accepted. And then we're going to go actually fix the issue. And then there's a bunch of other ones that are in here that we can triage as well. But this link right here will take you exactly to the spot in the Stackhawk platform that you want to go to triage this scan. So if I click that, it will dump me right here once I get logged in. Oh boy.
Scott, well, you were, while you're logging in, we got a question, which is, so the tool is launching the app in a container and running the scan, correct?
That is correct. So in this particular configuration, the tool is launching the application as a totally ephemeral environment in Docker containers, and then launching the scanner in a totally ephemeral environment. They're talking to each other while it's doing the scan, and then they all go away. That is the super ephemeral way to do this. This also works with if you're deploying services to a staging environment or a staging application in GitLab. You can pull that information back into the configuration file and tell the Stackhawk scanner to go hit that staging environment or that temporary GitLab environment. So now that I've gotten into the Stackhawk platform, this is the scan that ran. And you can see I've got one open high, and that's cross-site scripting guy. And then I've also got a couple of mediums and false positives. Here's that plugin summary. So there was a question about what rules actually run. Here's where that you can see what's running against each application. And each of these, some of these are disabled and they get skipped. And they get skipped because I've turned off technology flags in my Stackhawk configuration. And I'm going to show you where that is because it's super important. If I flip over to applications here and I take a look at the configuration for my AAA Vulny Django, Vulny Django likes to be at the top of the yellow pages for all the people that have ever seen yellow pages. Down here in technology flags, I have told Stackhawk what technology I'm using, or more specifically, what technology I'm not using to build this application. So you can see I'm using Postgres and SQLite. It's written in Python. I'm using Linux on the backside, or the container, the OS. I'm using Git, and I'm using maybe not Apache, but we'll test for Apache stuff anyway. And that is what has turned off some of these plugins, right? So I'm not testing for, here we go, down here. I'm not testing for MySQL. I'm not testing for Hypersonic SQL. I'm not testing for Oracle. I'm not testing for MS SQL. This does a couple of different things. One, makes the scan ripping fast. And two, reduces false positives because it's not testing for things you don't have in your stack. So that's really good. The other thing that's important here is this is all the paths that the scanner thinks it's found, so you can get a good sense of how well it's covering your application. But we're trying to fix something, so let's go fix something. We're focusing on this cross-site scripting reflected. Again, this is that same screen we're looking at where we've got this evidence highlighted at the top, where it went into the application, so it's actually URL encoded here, and then where it came back out in the source code of the body. So now you can kind of quickly get an idea of how to recreate this particular issue. Again, this is all squished because I've got it set up weird. You can see it's on the polls search path. It was part of a post method. It's new. We should actually probably fix this. Oh, the other cool thing that's in here is this validate button. This turns all of this request into a curl command. So this is the curl command that actually generated this problem. You should be able to take this, copy and paste it, and rerun this thing and be able to recreate this particular issue. We're not going to go through debugging session on this one because I know where it lives. We'll go fix it. How is the endpoint URL crawled if the application is pure backend application? So if we're talking about REST API or GraphQL, or we don't have support for SOAP today, but it's coming. Then it's just a simple addition of saying in the Stackhawk YAML here, we can say API and then JSON. We can point at the Open API spec or the Swagger file that defines the REST API endpoints. Same thing with GraphQL, documentation at docs.stackhawk.com, kind of go through all this stuff. And then it doesn't guess, it just knows exactly how all that works. So that's a really good thing. Instead of trying to make it crawl single page apps to find all of your REST API endpoints, just test the REST API endpoints with the Swagger file. All right, so we've got this cross-site scripting reflected issue. It's actually in the search path. Let's see if we can figure that out. So if we search over here, and this particular thing was, we're looking for this kind of code. So we can just put that in there and see if it does exactly what we think it does. And you can see that our cross-site scripting has fired here. So we actually do have this problem. I searched for cross-site scripting and we found exactly that cross-site scripting, apparently, according to Django. So let's go look at our application here and see if we can fix this up. So I'm pretty sure this is on the results page. Nope, sorry, search detail. This is the search detail template in Django. Here's where we're dealing with it. And this is exactly how you get yourself in trouble with escaping content in Django. So there's a good reason to do this, and that is if you want to display email addresses. Say we want to say Scott at, and it will display email addresses without escaping it and making it look really weird. That's a good reason for wanting to do this. It should be done a different way because this also gets you into trouble with cross-site scripting kind of issues. So this auto escape off is what actually created our problem, our cross-site scripting issue in this Django app. If we undo this, say we do that, save that file, let us commit that thing to our repository. We'll fix our XSS and we will push that back to our repository. Our GitLab pipeline should pick up that change. All right, so it's picked up our change of fix our XSS. It's going to run through our tests again. We'll see what actually comes back out of this. And the other thing, yep, we'll see where that goes. Joe asked a really good question. Can you point the tool at a running application that is not a container deployment? And the question is absolutely yes. If you can reach the running HTTP endpoint, you can point the Stackhawk container anywhere you'd like. All right, so while this is running, this is going to do that Docker container build, so it's going to take just a little bit. Any questions about how this works or the configuration file or tips and tricks for GitLab pipelines? Rebecca, any questions? Does this make sense to you?
This makes, I might be biased because I've seen it a few times, but so far it's making sense to me.
All right, great. That's awesome. Hopefully everyone is still following along or is making sense to everyone. The last thing I wanted to do was just kind of show you the screen here where I can see all the scans that have run against Vulny Django. You can see I've got high issues showing up or not showing up a couple different times and triage things. How different will Stackhawk scans from pure container security scanners like Prisma Cloud, Twistlock, or Core OS? So Stackhawk is testing the application that's running in that container. It's not testing the container. So the issues that may arise from building a container with vulnerable packages or out-of-date containers, that's where software composition analysis tools come in really well. They go, hey, you're using open source libraries to build this app that have potentially a problem. You could fix them. And your Docker image is using something that's vulnerable and you could fix that by upgrading name of the image you're pulling in for the base image, or adding some patching to part of the Docker build scenario. Hopefully that answered that question.
We will be covering that exact topic in a webinar with Sneak at the end of March, which you can certainly find on our website, and we'll also include a link to in the follow-up if you are interested in learning more about container security as well.
So the other thing I wanted to show you was this applications overview screen. So this will help give you an overview of all the applications that are in your environment, what's happening with them when they've been scanned, who's triaging things as what. So this is the one that we're working with today, our GitLab CI one. You can see we've still got one outstanding false positive. The other one I've been working with a ton is this development environment, so you can see all the scans and when they run and who has triaged things, etc. If you ever wanted to go, wait, why are all these things triaged as risk accepted, like in this one, in this Circle CI environment? If I wanted to say, what happened here? I can quickly jump to that last scan and see what happened in triaging. So we can see that this particular one got marked false. Oh, I clicked on it. I clicked on it again. Here we go. This particular Apache range header DDoS got marked as false positive, and we can see who did it. It was probably me. And it was updated by me. Hey, we don't use Apache. This is a great place to go turn off that Apache flag and tell Stackhawk, hey, we're not using Apache, so don't test for this range header DDoS.
So Scott, could you show us how to dismiss a false positive and also a sample report? That was a question we had.
Oh, sure. So if I wanted to dismiss a false positive, I would need one. Let's go look at this guy. First of all, here's where you do the scan report. So if you wanted to share a report of the latest scan with somebody, you could just do this print scan report. This is that same information all in a pretty format that has the same information there, as well as details about each of the issues. So this is good to share. I've actually shared ours with a couple of our customers and they find it very useful. But let's say we did this content security policy guy. Content security policy header not set. This is actually really an issue, but I could go, you know what, this is false positive. Comment is required. So now there's a comment logged. I can see who did this and when and read their comment. So if I wanted to come back in here as a security professional to do my trust and verify type activities, I could see what's happening here. I could go, okay, so Scott marked this as I don't understand this or something. I'm going to reach out to Scott and go, here's what this means. Here's why we should ask that. And then if I really wanted to be not nice, I could go, you know what, this is actually going to break the build and we should do triaging of this in a different way. So now I could clear status. So now these are all set back to new. They could trigger a pipeline break again if they wanted to, because these issues will now show up as untriaged again. Hopefully that answers your question, Joe. Let's see, where are we at with our pipeline? Our Hawk scan is running currently. So we can see that this has just kicked off. So here we go. We're creating that Vulny Django database. We're doing all the database seeding with this migration guy here. And then we're running the Django project itself. Once that's up and running, we start running the Stackhawk scanner. Again, you can see the Stackhawk configuration files have been stacked together in overlay mode so that we get the different host name and the different environment name, which are right here. And that scan has started. So now on the Stackhawk platform, you can see that the scan has started. And as we get in here, we can start seeing findings already. The scan is not completed, but we see things starting to flow in. So this is kind of real-time results being fed back to the platform. Again, our paths are getting populated. Some of our findings are starting to come in here. And as soon as some of these start finishing up, our plugin summary will start firing. Lots of interesting things are happening, but let's hope that we've fixed our XSS and it doesn't fire off in here. There we go. So here's where our plugin summary starts going. So I can start seeing the tests that are getting run against my application kind of in real time and how many tests are being run against the application. So We're working on path traversal right now, and then we're going to work our way through the rest of this list. Should be really good information. I do want to tell you that this build is going to fail because of a bug in HawkScan that we just found the other day while I was prepping for this demo. There is also, I'm going to show you over here, there's also a SQL injection in this app that is not getting loaded to the platform during the scan. There's a hot fix coming out for that later today. Otherwise, this would have been a really awesome demo. So there's a SQL injection right here on the PostgreSQL database. So this high should pop again, and it's going to break our build, but our cross-site scripting thing should go away because I believe we fixed it. So hopefully that pipeline comes out the right way.
So Scott, if those plugins are running,
yes,
but let's say my scan times out because I was scanning a really big app, what happens to everything that's already in the Stackhawk platform?
Yeah, so it stays in here. And that's one of the cool things that we did was to be able to start pulling all these alerts off of that HawkScan container as the scan is running, so that if it fails or the pipeline times out and it kills off all the things in the pipeline, or you've got a huge app where it takes forever and just won't finish, or we haven't seen that very much since we allow you to segment and microservice down all this stuff. All these alerts will end up in the platform. So you can still triage things. You haven't wasted your time and effort trying to get this information back out. You can see we're working on this PostgreSQL injection stuff right now. We did, again, find those 2 issues, so we should be able to see them. But I believe our cross-site scripting up here doesn't look like it found any issues, so we should be able to jump back to the findings, see what's going on. Scan is still running, but good point, Rebecca. Even if your scan takes a long time, or it fails, or it errors out, all the things that it found before then will get uploaded to the platform.
And can I triage while it's running?
You can triage while it's running. So this thing is still running. I can start getting in here and going, what is the content security policy not set? Yep, you're right. It's definitely not set. We could go fix that as well. And then let's see what else. Insecure HTTP method put. You know what? I'm going to risk accept these because I believe in put. Oops, there we go. So now those are marked as risk accepted, and they should not try to bring people's attention to the next scan that fires up after this. Our scanner is still going. Hey, look at that. So you can see that SQL injection is still fired off, but our cross-site scripting issue is gone. Now the Stackhawk platform doesn't think we have any actual issues, but our build still broke because of that one outstanding high. Again, that's a bug. Sorry for the terrible, terrible demo. But because there was still a high issue, and we set our build pipeline up to break on highs, and we allowed that job to fail in GitLab pipeline. Now I still have this failed job because there still are outstanding highs. So that's how we broke this particular pipeline. If you wanted to do that, again, we could allow this pipeline to pass with the GitLab configuration, and Stackhawk by default will not break a build unless you set that failure threshold. Joe asked, can I customize the checkers that will run, for example, skip logout tests? You can tell it to skip paths. So if you have a logout path in your application, you can do that via an exclude paths. So here, very similar to what I've done. So it won't even test any of those paths on the logout, which should prevent you from logging yourself out, which is exactly why it's in this particular app. And the checkers that run, again, that's the technology flags that we have in there. So if you set up a REST API endpoint in the configuration, we'll auto load a policy down that actually is really, really good and optimized for testing REST APIs. And then if you undo those technology flags in the platform, we'll only test for the technology you're using to build the application and not all of the technology. at that. My page has to reload and I get to go all the way to the end again. Tab suspender for the win.
Well, while Scott is jumping to the last slide in his presentation, feel free to drop any more questions you might have in the Q&A or in the chat. We have quite a few. We have 13 more minutes that we're here, so if anyone has any specific questions, we're happy to answer those. But take it away, Scott.
Quick recap. If you're using GitLab pipelines, add security testing to your pipelines, just like unit and integration tests. Get that feedback to the people that are writing code as soon as you can. Simple checks greatly improve your security confidence. So all the stuff that specifically DAST that you could run against your application before you put it into production is exactly the path an attacker would take to try to find problems in your application. So if you understand what you're putting out there from a DAST perspective and fix them or mark them false positive, etc., you're increasing the cost of a threat actor to try to attack your application. As I mentioned, software composition analysis and dynamic application security testing are great places to start. If you feel like you need more after that, then continue to add more on those layers. And then make sure your GitLab pipeline is keeping you honest. Block builds for issues that you can action, and then make that part of your normal workflow. Use tools that allow you to triage as a developer. Consult with the security team on what to fix, not finding things to fix. So what that means is don't ask your security team to go find all the issues they can. There's little value in that. Ask them to help you prioritize what things to fix. And then lastly, Rebecca mentioned this earlier, but you can sign up for a free developer Stackhawk account at that URL right there. Joe once again asked, how is the tool priced? Well, the free version of Stackhawk is in fact free for one application. So that's how that one's priced. But normally we price it by who has access to the platform to be able to triage issues and look at that request response panel and then mark things as push it to a ticket. So we could have pushed that to a Jira Cloud ticket. We chose to fix it, which is interesting. Or you could mark a false positive or mark risk accepted. And that's how we price the platform, is by user. Any other questions? Hopefully everyone found this super, super valuable. For those people that were not here early.
Ooh, we got a question, Scott, which is it available as a SaaS service only?
It is available as a SaaS service only. There's a ton of power in being able to ship that information back to our platform so that we can gather all of that false positive information. If lots of people are marking something as a false positive, we can undo it from a lot of different, from the Stackhawk platform itself so that everyone gets the benefit of that. We also feed that information back to open source, what things are getting marked as false positives so that people that write those tests and checks can fix them with better information. But yes, today, SaaS platform only.
Perfect. Well, Scott and I, like I said, we're available, so feel free to keep the questions coming. We really appreciate everybody joining us and taking the time to be a part of this. Feel free to reach out to us. You can reach Scott at Gerlach on Twitter or Scott at stackhawk.com. We'd love to hear from you.
That's right. Thanks, Rebecca. Thanks for moderating my Q&A and all that good stuff and keeping me on track and on task.
Of course. Of course.
One last shot of Snowmageddon for everybody. Look, Snowmageddon. Oh no, that's just a screen.
Your windscreen.
It went. It was funny, and then it went sideways. Oops.
Okay, I saw it earlier. Really.
Yeah, sorry.
It really.
No fun.
Awesome. All right. If we don't have any questions, I'll go ahead and end the webinar. Thanks everybody again for joining us. And we hope to talk to you soon.
Thanks everyone for spending some time with us. I hope this was super useful and insightful. Hopefully you can get some more things added to your GitLab pipelines.
Awesome.